Hello. For this video, let me introduce to you the concept of inventory optimization models. To introduce to you inventory models, let me give you a very classic example. No? This is called the Mortimer Middleman problem. Who is Mortimer Middleman? Mortimer Middleman, or MM, is a trader of diamonds. MM travels to Belgium to replenish his supply of diamonds, which, upon going back to the Philippines, he sells to his customers. Mortimer Middleman purchases his diamonds at a wholesale price of $700 per carat. And according to the supplier, whenever Mortimer Middleman orders, he has to order at least 100 carats. Next, Mortimer Middleman has a lead time of 1 week. What is lead time? Lead time essentially is the time between Mortimer Middleman wanting to order or ordering and actually receiving the order. So just to give an example that probably is more relatable to everyone, in general, Pizza Hut delivery has a lead time of 30 minutes. Why? Because when you order in Pizza Hut, you will be able to get your pizza generally after 30 minutes. And therefore, the lead time is 30 minutes. In this case, for Mortimer Middleman, what does lead time of 1 week mean? It probably means the time that it takes for Mortimer Middleman to book his ticket, to book his lodging, no, hotel stay in Belgium, Mortimer Middleman actually flying to Belgium, Mortimer Middleman actually going to the supplier and purchasing the diamonds, going back to the Philippines, and only when Mortimer Middleman is in the Philippines, that is the only time when Mortimer Middleman can actually sell the diamonds. No, so that entire process of booking, going to Belgium, and coming back will probably take 1 week, and that is your lead time. Okay, let's say the trip cost, no, round trip to and from Belgium is $2,000 per trip, and uh, Mortimer is selling 55 carats of diamonds per week. No? And to make it simple, we will be assuming that this demand is uniform and linear. Mortimer Middleman incurs a holding cost of $3.5 per carat per week. So what does that mean? That means that as long as Mortimer Middleman holds inventory, no, as long as Mortimer Middleman has diamonds in his inventory, he is incurring a cost of $3.5 per carat per week. And finally, according to Mortimer Middleman, he doesn't allow shortages, which means he cannot let his inventory go below zero, or technically down to zero. Now, remember that in any optimization model, in any mathematical model, we generally have four components: no? The parameters, variables, objective function, and constraints. So what we will be doing now is to identify the different components in an inventory optimization model. So first, what are the parameters? You may want to look at the Mortimer Middleman example for your reference, but here are the different parameters that I've identified in the Mortimer Middleman problem. First, the fixed ordering or setup cost. What does the fixed ordering or setup cost entail? These costs are the costs that you incur because you are ordering inventory. And these costs are fixed, meaning it doesn't matter how many inventory you are ordering, whether it's small or big, you will be paying a fixed amount. In the case of Mortimer Middleman, that is the $2,000 trip cost, no? because whether Mortimer will order a lot or just a few, he will still have to book his trip to Belgium, stay in a hotel, go to the supplier, etc., etc. And that is 2,000. And in general, we will denote the fixed ordering or setup cost to be the constant K. Next, the next parameter is called the unit variable cost. No? The unit variable cost, I think, is easy to understand because this is the cost of purchasing the inventory or the unit from your supplier. And this is denoted by uh, the constant C. In Mortimer Middleman, the unit variable cost is $700 per carat. Next, the unit holding cost. The unit holding cost is the cost that the company incurs because the company is holding or keeping inventory, no, in its storage, and the holding cost is dependent on how much you are holding, how much, no, how many units you are holding, and how long you are holding that amount. And that is why the unit for the holding cost is some money value. So let's say Philippine peso per unit per time. Okay, and this is denoted by the constant H. Next, the next parameter is called the unit shortage cost. In the same way that the unit holding cost is a cost per unit per time, the unit shortage cost also has the same unit, no? Pesos per unit per time. Although Mortimer Middleman said that in his model he does not allow shortages, however, there will be some cases wherein the company will allow shortage. What do we mean by shortage? It means that you are technically still using up your inventory or selling your inventory even if the physical amount of your inventory is already zero. In fact, a shortage in the company's inventory is actually seen as negative inventory. And this unit shortage cost is denoted to be the constant P. Next, we also have the parameter demand rate. And this is the rate at which you use up your inventory. No? And we denote it to be the letter A. Next is the supply rate. What do we mean by the supply rate? The supply rate is the rate at which your supplier um, is able to give you your inventory or supply you your inventory. In general, we assume B to be infinity. What do we mean by this? No matter how many you order, if B is infinity, that means your supplier is able to give you your order all at once. However, if B is, for example, let's say 100 carats per day, and Mortimer Middleman orders 300 carats, then this supply rate of 100 carats per day means that the supplier will be able to supply the order of Mortimer Middleman, which is 300 units, in a total of 3 days. Diba? Because the supplier is able to deliver 100 carats per day and Mortimer Middleman orders 300. Therefore, the number of days in which the order of Mortimer Middleman will be fulfilled is 3 days, and that is your supply rate, no, yung 100 units per day, and we will use the letter B to denote the supply rate. And finally, lead time. No, as I have explained, lead time is the time between you ordering and actually receiving your units, your inventory. And in this case, we will denote lead time to be the letter L. Next, we have our decision variables. And how many decision variables do we have? We, in general, have three decision variables. Although, as we discuss the different models under inventory models, no, there may come a time wherein we have to define additional variables. But in general, we have three. Okay, the first one is Q. Q is the reorder quantity, meaning this is the amount of units that the company, or in this case, you, will order from the supplier every time you will order. Next, R. R is called the reorder point. What is the reorder point? The reorder point is the point in your inventory that will signal to you that you need to reorder again or already. So for example, let's say let's say you own a J6 stall, and let's say one of your main inventory is chicken. And let's say your reorder point is let's say 2 kilos, and your reorder quantity is 20 kilos. So what does that mean? If today you look at inside your refrigerator and you only see 2 kilos of chicken, then that will tell you you need to call your supplier. And when you call your supplier, you order 20 kilos of chicken. Okay? So that is your R. It's the point in which you need to reorder again. Finally, T. What is T? T is the cycle time, or in this case, the cycle time is also the time between two orders. So if I order now and I order again 2 days after, then cycle time is 2 days. Okay? And the unit of T is in terms of time. Obviously, the unit of Q and R is in terms of units, whatever the unit is. Next, what is the objective and the objective function? For inventory models, we usually minimize the total cost. Okay? Some would say we want to maximize revenue, or we want to maximize profit. However, I think, well, in the first place, there wasn't any revenue or profit mentioned in the problem. Secondly, even if there was a revenue or a profit parameter given in the problem actually revolves around trying to look for the optimal, let's go back, trying to look for the optimal reorder quantity and the reorder point, such that your ordering cost, no, your ordering cost is low, your variable cost is low, your holding cost is low, your shortage cost is low. Actually, let me clarify that. Your ordering cost plus your variable cost plus your holding cost plus your shortage cost, or your total cost, is minimized. Why are we focusing on the cost? If you notice, and let us focus on the main variable, which is our reorder quantity. Okay, if your Q, your reorder quantity, is very high, no, is high, then you will notice that ordering cost is low. Why? Because if you order a lot from your suppliers, then your number of orders will be just a few, no, mababa, and therefore your total ordering cost is low. However, if your Q is high, then your holding cost is high. Why? Because you're ordering a lot, therefore you need to keep a lot in inventory, therefore this is high. Okay? Uh, the variable cost and shortage cost, I will explain them as we go along the way. But if we were just to focus on these two, ordering cost and holding cost, if Q, no, if Q is very high, if Q is high, then this is low, this is high. On the other hand, no, if Q is low, then this is high, this is low. If your reorder quantity is very low, then you have to keep on ordering very often. And that is why your ordering cost is high. However, because you are just ordering just a few, then your holding cost is low. And as you can see, you have two cost components that behave differently, in fact, inversely. And that is why we need to look for the optimal reorder quantity. Okay? And that is why our objective function is to minimize the total cost. And again, even if we do have a revenue parameter, and even if we change our objective function to maximizing the profit, no? In this case, your profit is equal to some revenue minus your total cost of inventory. No? But because revenue is constant, why? Why is revenue constant? Because you have your selling price and you also have your demand, both of which are uniform and constant. No? Therefore, this is your total cost. Therefore, your maximized profit, which is equal to this, if this is fixed, no? If this is fixed, then technically this is the same as saying you want to minimize your total cost. Okay? There are a lot of constraints that we can take into consideration. However, in most of our discussions, we will not take into consideration some constraints. But let me give you some possible constraints that you may encounter. First, it is very possible that you have storage capacity. So you have a maximum number of units you can store in your warehouse, let's say. There is also a possibility that you encounter delivery storage capacity. For example, let's say pizzas. No, I doubt a Grab or a motorcycle driver can deliver 100 pizza boxes at a time, diba? The next possible constraint is, for example, a minimum stock level, meaning some regulatory board requires you to have a minimum of, let's say, 100 boxes of whatever. Let's say you're a bank, and let's say your inventory is money, no, and if I remember correctly, the BSP requires the banks to have a certain level of deposits, no, that are not being lent out to businesses. That can be your minimum stock level, no. Of course, there are also other constraints that we can encounter, no, in the future. And finally, there will be two general kinds of inventory models that we will be talking about, no, for this module. One is called your deterministic demand, and the other one is called your probabilistic or your stochastic demand. I hope it is very clear when we say deterministic demand. In an inventory model that has deterministic demand, that means your demand is known in the first place. Secondly, it is constant. If you remember the demand for Mortimer Middleman, it was 55 carats per week, no, and it was assumed to be uniform and linear. Therefore, Mortimer Middleman has a deterministic demand. On the other hand, if we change the demand pattern in Mortimer Middleman and say that the demand is known, no, demand is known, and yet demand follows a normal distribution, let's say. Now, if demand follows a normal distribution, then it becomes a probabilistic inventory model. Okay. For most of our models, we will be dealing with deterministic demand. Okay. Now, under deterministic demand, we do have several variations. the most common is continuous review. What do we mean by continuous review? Continuous review means that at any point in time, there is demand that is happening, or you are consuming your inventory at any point in time. And this is in contrast with periodic review. A periodic review inventory model assumes that the consumption or the usage of your inventory only happens at specific points in time. Now, maybe to illustrate, let me quickly explain possibly uh, the difference of continuous and periodic review via a graph. For continuous review, if this were your inventory level right now, it will slowly decrease over time. Okay? So the movement of your inventory looks like this. Because at any point in time, your inventory is decreasing because the assumption is you are using inventory at any point in time. However, if your inventory model uses periodic review, then if you are currently at this inventory level, it is very possible that your inventory level looks like this and then suddenly it goes down. No? So from this point to this point, you don't encounter any usage of your inventory because your usage of inventory is at certain periods, and in this case it only happens at this point, no, at this point where your inventory level suddenly goes down. Okay, and that is the difference between the continuous and periodic review. For our purposes, for our discussions, most of the inventory models that we will be discussing is continuous review. Finally, a variation of the deterministic inventory model is the addition of what we call quantity discounts. What are quantity discounts? This is the phenomenon where your supplier will offer you additional discounts in the form of a reduction in the unit variable cost because you are ordering more units. No? So this is where economies of scale will come in. Ito yung when you order a single Krispy Kreme donut, it costs you 40 pesos. But once you order 6 pieces, no, a box of Krispy Kreme, then from 40 pesos per donut, it now becomes, let's say, 35. And then let's say if you order 2 boxes, 12 pieces, then let's say per unit, the donut unit variable cost, let's say, goes down even further to 30 pesos. This is what we mean by quantity discounts. On the other hand, for probabilistic demand, we will focus on a single type of inventory probabilistic demand model called the newspaper boy model. And what is this newspaper boy model talk about? It talks about a single period where your inventory is, how do we say it, effective. I think the best example for a single period probabilistic demand is the bakery, no, whether it's French baker or your street side bakery, no, your local bakery. If you understand the business of bakeries, you will understand that any excess bread, no, bread baked, or any bread that is left, no, in your inventory after the day, generally cannot be sold anymore the next day. Why? Because people generally do not want day old bread. No, they will always want to purchase freshly baked bread, and that is why if I'm the baker, no, my inventory for baked goods, for bread, is only effective, in quotation marks, effective for a single period. And in this case, my period is a day. In the same way, the newspaper boy will have a single period as well. Why? Because his inventory is newspaper. And obviously, uh, tomorrow, the newspaper today will be useless already. Okay? And the variation here is that there are probabilistic models where you have setup costs, and you also have probabilistic models where you don't have setup costs.